Hello friends, I think I am audible, okay, and visible also. So today we are going to talk about sampling and sampling distribution. Here I will explain different types of sampling and sampling distribution, and what is this sampling and sampling distribution, and then after I will explain different applications of sampling distribution also. Okay, so one by one, let's start. So here the first thing which is given, that is sample. Okay, what is given? Sample. So as you can see on your screen, here, sample, the portion of population that has been selected for analysis. It means that portion of the sample which we take for analysis, that portion of the population is known as sample. Okay, why we take sample means we can do the analysis of the whole population also, but we don't do that in so many cases, and in so many cases we used to take whole population for the analysis, just like in case of census we take the whole population for analysis, but most of the cases and you can say in most of the business situations we don't take the whole population, because for analyzing the whole population it requires a lot of resource. Okay, so that's why we take only a part of the population for the analysis purpose. Okay, so here given reasons for selecting a sample. So what are the reasons for selecting the sample? Why we take sample at the place of whole population? So the first reason given, less time consuming than selecting every item in the population. So that is true. If we take each and every element of the whole population, then analyzing that it will take much more time. Okay, and if we take only a part of that population, then it takes less time. So that's why that is the first reason. The second reason is that selecting a sample for the analysis, it is less costly, because we have less number of elements, or less number of, you can say, people whom we have to analyze. So that's why it is very important that we take less number of you can say sample. But we also need to consider that we need to take at least that much amount of sample which is very good predictor of the whole population. So those things also we will talk about in the later sessions also, but here now this is the reason, the second reason. Third reason given, less cumbersome and more practical than an analysis of the entire population. Okay, it means analyzing a sample, it is less cumbersome. Okay, less cumbersome means it is less tedious and more practical than analyzing the entire population, because it is common sense that when you analyze the entire population, then in that case it takes more time, more money, and a lot of effort, mental and physical effort required for analyzing. So that's why it is less cumbersome to analyze sample as compared to the entire population. So that's why we select a sample for analysis. Okay, that's it. Reasons for selecting a sample you got. Now next, here given types of sampling methods. Okay, types of sampling method. Okay, let me check whether battery it is charged or not. Okay, it is charged. So types of sampling methods. So basically two types of sampling methods are there. The first sampling method, it is non-probability sample, and the second, it is probability sample. So what happens in non-probability sample and what happens in non-probability? So sorry, what happens in non-probability sample and what happens in probability sample? So now let's see. So in case of non-probability sample, you select the items or individuals without knowing their probabilities of selection. It means when we select the elements in case of sample selection, and if we do not know the probabilities of those selected elements, then that kind of sampling is known as non-probability sample. So that's why here it is written on the screen that you select the items or individuals without knowing their probabilities of selection. It means we do not know exactly the probabilities of the elements, or in other words you can say we do not know the probabilities of selection. Okay, so here non-probability sample given two types. So first it is given convenience sample. Convenience sample, what happens? Items in convenience sample, items selected are easy, inexpensive or convenient to sample. Okay, in many situations, according to our convenience or the ease with which we can collect the sample or we can take sample for analysis, so that ease decides or you can say that ease make us to select a particular sample. Okay, so that's what happens in case of convenience sample. So the next one given the judgment sample. So in case of judgment sample, here we get the opinions of pre-selected experts. It means here we select some experts, okay, in the subject matter, and according to those experts or you can say according to the opinions of those experts, we select sample. Okay, now next move on to the probability sample. Okay, so non-probability sample you got, and now here you have probability sample. So what happens in probability sample? In case of probability sample, you select items based on known probabilities. It means you know the probabilities of sample selected. Okay, so types given, the first that is simple random sample. So in this every item from a frame has the same chance of selection. Okay, it means each and every item from the frame has the same chance of selection as every other item. It means whatever item you select from the frame, from the same frame means from the whole population. Okay, the probabilities of those selected items will remain same for all. So every sample of a fixed size has the same chance of selection as every other sample of that size. Okay, now that is the can select samples with replacement or without replacement. In case of simple random sample, we can select samples with replacement or without replacement. So what happens in case of replacement and what happens in case of without replacement? In case of with replacement, what we do, we select we select a particular sample, and then after selecting, so those the selected samples are replaced with them, means we take and then after we put those samples again in the population. Okay, and in case of without replacement, what happens? Now here given sampling with replacement means the here given that after you select, okay, if I write then it will be better. So let's select a particular color, red, orange. This is red. Okay, So now you can see here given sampling with replacement. So after you select, so now you can see here, after you select an item, you return it to the frame. Means after selecting the item, you return the selected item to the frame from where you selected that item. Okay, so that's, and now in case of sampling without replacement, means here now you see B, without replacement means given you select an item, you cannot select it again. It means when you select an item, you don't put that selected item again into the frame. Okay, you don't put. So what you do, you take out the sample selected, and then after you do not put back the selected items into the frame. So that's what happens. Okay, so that it was about a simple random sample. The second one, it is systematic. Second one it is, so here you can see second one, it is systematic samples. Systematic samples means here given in a systematic sample, you partition the n items in the frame into n groups of k items. Okay, so here what you do, if you have n items in the frame, then you group those items into n number of groups. Okay, what you do, you can say categorize, or you can say you group those items into n number of groups having k items. Means k is the number of items in each group. Okay, k is the, here it is given a k items, it means k is the number of items in each group, and the number of group here given n. Okay, so that's given. So k means number of items in each group will be equal to total item, means that is capital N divided by n. Okay, so here given a systematic, you partition the n items in the frame into n groups. So it means simply in case of systematic samples, you divide the whole item, means all items in the frame into n groups, and each group contains k items. Okay, and then you select the sample from the frame. Then you have next that is stratified samples. So in case of stratified samples, so given you first subdivide the n items in the frame in, you can see here n items. Okay, what you do, you subdivide the whole frame into, in the frame into separate subpopulation. Means the whole population is subdivided into subpopulation. Okay, or strata. You select a simple random sample within each of the strata. Okay, means if you have the whole population, so you are going to subdivide the whole population. So now you can see here on the screen, you can see if this is the whole population, and this population you are going to divide into many parts, just like here you can see on the screen. So 1 2 3 4 5 6, in 6 sub population I divided the whole population or the whole frame. And then you select a simple random sample within each. It means from this first one you select anyone. So in this many are there, and in this one also many you can say elements are there. So means in the same way here you have in this all you have many elements. And what you do, so from these all, just like here the first subpopulation, second, third and fourth and fifth and the sixth, here from these all 6 subpopulation you select elements. Okay, so that's here given. You select a simple random sample within each of these strata and combine the results from the separate simple random sample. It means from the first one you select any number of, for example, if you select 2 from the first subpopulation, and 2 from the second subpopulation, 2 from third subpopulation, 2 from fourth subpopulation. In the same way, you select 2 elements from these all subpopulations, and you combine those all subpopulation. No, yes, from these all 6 subpopulation, you select 2 elements, and you combine those all elements, then we get stratified sample. Okay, and the selection of elements from these all subpopulation is random. It means randomly you select the sample from these subpopulation. Then next you have cluster sample. So what happens in cluster sample? You divide an items in the frame into several clusters. Okay, several clusters, so that each cluster is representative of the entire population. So now you say there is a difference. Here in case of a stratified sample, subpopulation 1 is not the representative of the whole population. Okay, it is not the representative of the whole population, that is only the part of the population. And by combining the elements selected randomly from these all 6 subpopulation, you get the representative representative elements for the entire population, or for the entire frame. But in case of cluster sample, what happens? Here I'm drawing here, if you have this one the whole, and inside this one just like 1 2 3 4 5 6. Okay, in the same way many clusters are there. So just like here cluster 1. Okay, if I use different color, then it will be better and it will be visible. So now green. Okay, now you can see this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So 1 2 3 4 5 6. So 6 clusters are there, and each cluster is the representative of the whole or you can say whole population. So that's given in a cluster sample. You divide the n items, so n item means all items present in the population in the frame, into several clusters. So now here I divided the whole n items into 6 clusters, so that each cluster is representative of the entire population. So it means cluster 1, cluster 2, cluster 3, and so on. These all clusters are representative of the whole population. Okay, now next you then take a random sample of 1 or more cluster and study all items in each cluster. And then what you do in case of cluster sampling, you select any one. Just like here 6 clusters are given. Out of this 6 cluster, you can select any one, and after selecting any one, you study, or you can say you study all items from the those selected clusters for statistical purposes. That's it about here. Now I think we have more time, so we can talk about sampling distribution or not. Okay, sampling distribution I will explain in the next session. Okay, so I think thank you all, and if any kind of query, then you can ask me.